right, so now we got day number 2. Today we are going to be talking about 9.4, area and perimeter of regular polygons. Our objective for today is to calculate the area and perimeter of a regular polygon. Make sure you have this title down in your notes, and we will begin. So perimeter of a regular polygon. Do not write this down, just listen and read as I read aloud. Recall that a regular polygon is a polygon with congruent sides and angles. So that means to be regular, you have congruent sides and all the angles are the same. In this section, we are going to deal with regular polygons because they are the only polygons that have a consistent formula for area and perimeter. First, we will discuss perimeter. Recall, perimeter of a square is 4 times the length of each side because each side is congruent. We can extend this concept to any regular polygon. So if I want the perimeter of a regular polygon, the length of a side is S, and there are n sides in a regular polygon, then the perimeter is equal to P equal to N times S. Go ahead, let's click pause and write this one down. All right, so example number 1 says, what is the perimeter of the regular octagon with 4-inch sides? So one way you can look about this, if they say octagon, we know it has 8 sides, or you could just count how many sides are around the shape. If each side is 4, following P equals N times S. Perimeter is equal to number of sides, 8 times each side length, 4. 8 times 4, 32 inches. Make sure we label our unit measure. Example number 2 does not have a picture. It says the perimeter of a regular heptagon is 35 centimeters. What is the length of each side? So first you have to ask yourself, how many sides are in a heptagon? Heptagon is 7 for those of you who do not know. So we use perimeter equal to number of sides times their length. So my perimeter is 35. It's equal to my number of sides, 7, times their length. I want to get the length all by themselves, so I divide by 7. And each side is equal to 35 divided by 7, 5. Specifically though, 5 centimeters. Area gets a little bit trickier. So we're going to start off. I'm going to put my screen shade up. Area of a regular polygon. All regular polygons can be inscribed in a circle. So regular polygons have a center and a radius. Which are the center and the radius of the circumscribed circle? Also, like a circle, a regular polygon will have a central angle formed. The central angle, though, is the angle formed by the 2 radiuses drawn to consecutive vertices of the polygon. Take a moment and write this down. All right, so we have our circle. And notice I have a green polygon on the inside. Label your center A. I have two radiuses that come out of the center. And then down the center to the outside of one of the sides is something called the apothem. Again, let's click pause one more time so that way we can copy this one down. I will spend some time explaining this as well for you guys, but it does correspond to the words above. All right, so notice that I have the central angle is BAD. So I'm going to have to take my cursor and point here. BAD, central angle. Also, notice that the triangle BAD is an isosceles triangle. I know that it's an isosceles triangle because my radiuses are congruent. And if we have an isosceles triangle, we know that the base angles are congruent to one another. Every regular polygon with n sides is formed by an isosceles triangle. But if we have a regular hexagon, 6 sides, then the triangles are equilateral. The height of these isosceles triangles is called the apothem. Apothem is that red line that goes through. Again, let's take a moment so you can write this down. All right, so let's talk about this apothem a little bit more. It is a line segment that's drawn from the center of a regular polygon to the midpoint of one of its sides. We can also say that the apothem is perpendicular to the side that it is drawn to. And by my isosceles triangle theorem, again, that's sticking back into our brains a while or just flipping back into our notes, the apothem is the perpendicular bisector of the side of a regular polygon. Your apothem is also the height or altitude of an isosceles triangle. So as you write that down, I'm going to explain a little bit more. Given an isosceles triangle, I have an apothem. And we can also call this my altitude because we know my altitude forms a 90-degree angle. Now, with the apothem, and it's saying it's the perpendicular bisector. That then means it cuts the bottom base into 2 congruent parts as well. We are going to be using this as we start to find the area of my polygons. Let's go ahead and click pause, make sure we all have this down. So let's do an example where we're asked to find the apothem. So we want to find the apothem of the regular octagon. We want to round our answer to the nearest hundredth. Again, take a second, try and draw the octagon. If it's not perfect, guys, it's all right. Basically, we're just dealing with that triangle that's inside of it. Okay, to find the length of the apothem, we are going to need to use trig ratios. So first we need to find the measure of angle CAD, so the central angle. Remember that any polygon fits inside of a circle. We know that all circles' degrees are 360. So I'm going to go ahead and take 360 and divide it by however many sides my polygon has. Since we have an octagon, we are going to take 360 and divide it by 8 to get that central angle CAD. 360 divided by 8 gives me 45 degrees. So the measure of angle CAD equals 45. Again, that angle is right here. Now I can use this to find the other two angles in the triangle CAD. Remember, all triangles add up to be 180. And again, just like we said before, every single polygon forms isosceles triangles. So I know that angle C and angle D are going to be congruent. Since triangles add up to be 180, I'm going to take 180, subtract 45, and take that answer and divide it by 2. I get 135. Again, we divide it by 2 since it's being split up with two angles. To get that angle C and D are 67.5 degrees. All right, so now I'm going to use this information so I can find my apothem. Had a little hiccup in the recording, I apologize. All right, so essentially we have this triangle. So let me go back real quick so you can see it. Looking right here at CAD, I've just now expanded it to be a little bit larger. So if we look at the triangle CAD, we have labeled that CAD was 45 degrees. My apothem cuts the triangle into two congruent parts. So half of 45 is the 22.5. And then we have the angle D, which we said was 67.5. We were told that each side length of this was 12. Half of 12 is the 6. And I'm just going to look at that right triangle. So if my goal is to find the apothem, what I've outlined in black, I can go ahead and say that's X. How do I find the missing side length if I do not know two of them? Well, I know their angle measures. So if we use 67.5, what relationship does 67.5 have with the X? It is opposite. And my 6 relationship is that it's the adjacent. So if I think about my trig ratios, so on. Who has opposite and adjacent in it? Tangent. So I'm going to take tangent of that angle, 67.5, equal to the opposite, my X, over my adjacent 6. How do I get X by itself? Multiply by 6 on both sides. So X equals 6 times tangent of 67.5. Round our answer to the nearest hundredth. And I get that the apothem is 14.49. Remember, guys, if we need to, just ask Ms. Grover to take the slides and reverse them back a couple so you can re-watch this. All right, so we are going to use the apothem to find the area of any regular polygon. So let's continue with our next example. I want to find the area of the regular octagon. It's the same one from before. But now I've labeled that I have the apothem and I have a side. We know that an octagon has 8 sides. So it can be split up into the 8 congruent triangles that you see. If we find the area of one triangle and then multiply it by 8, we will have the area of the entire octagon. So area of a triangle equals 1/2 base times height. And remember, the height is the apothem. So my area here equals 1/2. My base 12 times my height 14.49. You can make it a little simpler. We know half of 12 is 6 times 14.49 to get 86.94. And since that's the area of just one of my triangles, and I have a total of 8, I'm going to take that number, multiply it by 8, to get that the entire octagon has an area of 695.52 units squared. So this is actually an area of a regular polygon given any certain amount of sides with a length of the sides. We can use the apothem, and we could either use area equals 1/2 ASN or area equals 1/2 the apothem times the perimeter. So you don't have to necessarily take whatever one triangle is and multiply it by the sides. If you find the perimeter first, you can use that as well. Let's take a moment, pause to write this down. All right, our next example wants us to find the area of the regular polygon who has a radius of 4. So go ahead and copy down this pentagon and give it a radius of 4. I'm going to start off by drawing the other radius line to create the triangle. So I know that it is also 4. If I cut this pentagon into congruent triangles, I'd have a total of 5 of them. I'm going to use that number 5, also the number of sides, to figure out what the central angle is before I start to find my apothem. So I take 360 and divide it by 5. And again, this is giving me that central angle. And I get 72 degrees. So now I'm going to go ahead and do away with the pentagon and just draw the triangle. I'm going to go ahead and add in the apothem, which we know forms a 90. Remember, my apothem cuts that triangle in half. So where my central angle was 72, if I take half of 72, each side is going to be 36 degrees. I label the apothem A, and I label my side of my pentagon N. Again, since our apothem cuts my triangle in half, what I've labeled in green is half of n, or 0.5 of n. So if I first want to find the apothem, I look at the right triangle. What relationship does the apothem, A, have with 36? It is adjacent. So my apothem is adjacent, and my 4, which is a given side, is my hypotenuse. Which of the trig ratios uses adjacent and hypotenuse? Cosine of the 36 equals the apothem, my adjacent, over my hypotenuse 4. To get the apothem all by itself, I multiply by 4 on both sides. So the apothem equals 4 times cosine 36. Type it into your calculator, round to the nearest hundredth, and my apothem is 3.24. Next, I want to figure out what n is. So I figure out that 36 and the 0.5n are opposite, and I'm going to use the 4 again, who is my hypotenuse. So I take sine of the 36 equal to 0.5 n over 4. So now our goal is to get the n all by itself. So the first thing I got to do is multiply by 4 on both sides. I get 4 times sine 36 equal to 0.5 is really the fraction of 1/2 n. The reason I changed it to 1/2 is now I'm just going to multiply by 2 on both sides to get n all by itself. This 2 only multiplies with the 4, and 2 times 4 is 8. Sine 36 equal to the n. Again, when you type it into your calculator, round it to the nearest hundredth, and I get 4.7. If you have to bump it up, you can leave it as 4.7. Now that I have these 2 pieces of information, I'm going to go ahead and plug them back into my area. That's equal to 1/2 the apothem, 3.24, times number of sides in a pentagon, 5, times the length of each side, 4.7. You can type all this into your calculator at once, and we round, and we get approximately 38.07 units squared. Again, if you need to watch this part again, you can always watch it on the website, or just ask to go back. All right, our last example. The area of a regular hexagon is 54 radical 3, and the perimeter is 36. Find the length of the sides and the apothem. So first, since I know the perimeter is 36, and I know a hexagon has 6 sides, I can go ahead and find the length of each side using perimeter equals s times n. Perimeter is 36 equal to sides times the number 6, divide by 6, and my length of each side is then 6. To find the apothem, I can use area equals 1/2 the apothem times perimeter. The area is 54 radical 3 equal to 1/2. I do not know the hypotenuse, so I'm going to leave it A, times my perimeter, 36. First thing I do, take half of 36. So I get 54 radical 3 equal to 18A. To get A all by itself, divide by 18. And leave it in terms of the radical. 15 divided by 18 reduces to an even 3. Radical 3. So my hypotenuse is 3 radical 3. And the sides lengths are 6. Again, guys, if you need to, watch the video again. It is on my website. Or ask Ms. Grover to replay parts of it that you need to right now. Or go to tutoring and ask another teacher to help you. Remember, you are going to have a quiz on Monday. You need to study for that quiz. I'm not going to tell you yet whether or not it is going to be open note, but it's up to you to study these notes, do the homework. I will see you on Tuesday.